The hardware that we have built utilizes gyroscopes from 2 different major suppliers, as well as accelerometers from up to 3 or 4 different suppliers at this point, and magnetometers from 2 different suppliers. The specific hardware that you saw demoed in the videos was definitely built with a single set of sensors. However, the software does not rely on that sensor set. Certainly, you'll find different performance from the different vendors out there, and we tend to help our customers choose the proper sensor for the application because of the time that we've spent with each of the vendors out there.
Okay. Could you actuate? There's a question. Could you actuate a medical device with this, or would it be more used for feedback and data in a device like that?
So we do have one customer, 2 customers now, in the European health market, utilizing it as a healthcare device. That was one of the videos you saw. It's a range of motion application for physical therapy. But what we've found is we've had customer feedback saying that the patients actually improve faster because of the feedback that they're able to get. We get much more accurate feedback and track it over time, and the patients are able to show improvement sooner, and therefore, from a mental state, end up doing their therapy more and therefore recover faster.
Okay. Do you have design kits available for designers to work with?
We do. We sell a Smart Motion Developers Kit. It's not just readily available on the website. We engage on a customer-by-customer basis.
Okay. And then there's a series of questions about limitations of the devices. Some are asking about the limitations with the 3A, 3G sensor compared to the 3A, 3M, 3G. And related to that, how do you qualify performance under the various conditions of the various sensors and your interface with them? So sort of multiple questions there, but maybe you can run with that for a bit, Tim.
Hey, this is Bruno. I try to answer that. So when we talk about motion feature, there are very different types of motion features. We've been talking about detection. We've been talking about estimation, where we want, like speed, orientation through time. And we also been talking about classification. So the set of sensors that you need is really dependent on what you look for. So what we've been showing in the combo demo is an estimation feature. So we want there to estimate the 3D angles in a dynamic situation, which is what people are looking for a full-blown motion feature. So that every sensor brings its piece of the information that is needed to bring this dynamic orientation to a product. So if you want the full-blown 3D orientation, you would need the 3 sensors. But you can have very different applications where you may want, a shorter delay for computing the orientation, so that you can maybe rely on 2 of these 3 sensors. So if you, for instance, don't want to have the absolute heading, and in some applications you may not want this absolute heading, you may get rid of the 3M sensor. So it really depends on what you look for. So basically you can go from ranging from 3G, and then you would not have any absolute orientation information, but in some cases you don't need. You can have a combination between 3G, 3A, then you won't have any information at the absolute heading, and you can have the full-blown combination 3A, 3M, 3G, which gives you dynamic orientation and both absolute orientation features. And this is the full-blown, from which you can try to compute acceleration, so that we can do that. And starting there, you can also compute trajectories.
Can you comment on both resolution about a fixed point and any sort of time lag that there is between the movement and the reaction? So
in terms of timing, it's just depends on how fast you sample the signal. So it also depends on if you want a wireless network, so that we have developed a motion pod system. You may want a very low time lag, so it depends on how fast you sample the signals and how fast you will have the data available on the system to compute the orientation. So in our wireless network, we have a very small time lag, which is running at the speed of the sampling signal. So this is 1/200 Hz. So this is the lag that we have for computing orientation. So we have done also other demos, like when the man is in the loop, like he was playing music with the pods, and so you really want there to have a very small lag between the action of the arm or of the foot and the event that it creates on the music. And it appeared to work very well with this kind of application where we had very hard requirements.
Okay, so reliability of pattern recognition then, for example, an example that someone gave here goes back to your medical application and a control actuator for prosthesis that needs to be, with no error and highly reliable pattern recognition. Is that a challenge you can meet then?
Yeah, because for medical applications, you have to go through, several compliance levels, so that we could prove that the system we brought to our customer were able to meet these requirements. So of course you have to be reliable in terms of calibration, so that the user doesn't have to cope with these problems, and so that in the end you can prove to the compliance people that your device is able to go to this market. So this product is also shipping, and so it proved to be reliable enough for this very difficult market.
Very interesting. In terms of calibration, there was one application at least showed that there was no calibration required. Is that true for many applications, or what is the calibration for other solutions?
So once again, calibration is very specific to the use case. So in the application we shown for sports, our customer wanted no calibration. So we just had to cope with that, and we had this motion feature could work on any sensor without any calibration, so that in the lifetime of the product, we don't have the end user doesn't have to recalibrate. For some other applications, you need calibration, so it can be done at the factory level. So we are now also experts in being able to do calibration, and we compute these calibration coefficients so that they are stored in the MotionIC, so that the end user doesn't have to perform any calibration or any heavy calibration in this application. And there are also situations in the use cases where the calibration can be hidden into just an initialization of the sensor, so that the end user goes through this calibration without even knowing it.
Okay. So then, let's see. There's still a lot of questions from the audience, and I don't know that we're going to get to all of them. And we apologize to any that we don't get to. There's another one or two that I'll take before that I wrap some of these into a general question for you guys to close on. But so there are questions about how powerful of a controller is needed to run the software. Is it anything out of the ordinary required to run your stuff?
Some of the applications run on very small 8-bit microcontrollers, detecting like a simple hand gesture, a swipe to the right or left, up or down. Those applications run on an 8-bit microcontroller. The gesture recognition engine has been running on processors that are typically found inside of television set backplanes, about a 250 megahertz ARM 9, ARM 11 style processor, and then of course PCs.
Okay. There's a series of questions related to Movea and people asking about, you know, how big you are, how well you're doing, what is your exact offer? Is it just software? Is it software? Can they get sensors from you if they wanted to? Those kinds of questions. So maybe you can talk to that a little bit here too. Like I said, there's a whole series of questions from the audience related to that.
Okay, I'll take that. So as far as what is the offering, it ranges. As again, depends on a customer-by-customer basis. We've worked in as simple of scenarios as a pure licensing, from providing software solutions or firmware solutions in a device, all the way to full product design where we work with the contract manufacturer to get it packaged and delivered to the end customer's distribution center. So I know that's a very general answer of yes, we work in lots of different ways, but we really do. We've engaged with different customers in different segments doing it in each of those scenarios. As far as buying the sensors from us, if the application warrants, we either can leverage the sensor sets, the ones that were actually used in the videos. Those are a product that we make. We tend to engage in larger engagements with those, though, so it would depend a little bit on the application and the end customer. We think that our advantage is that we have a very large or a very wide breadth of experience, as well as we've done real product manufacturing, and so we bring the last step, which is often the hardest step, of bringing that product to market through a contract manufacturer, understanding what calibration really is, understanding what quality controls can be held in the marketplace.
In these new markets, it's always interesting to have other people in them because it gives credence to the market. And as this grows, we're sure to see that Movea is going to lead the way in this space in providing solutions to help the functionalities from the MEMS world make it into the product world. And if any of you have ever had an opportunity to play with a gyration mouse or any of the other products enabled by these, really begins to open your eyes as to what this can do. You guys are doing a great job. I've been playing with your gyration mouse for quite some time now, and I'm really impressed with it, and it really brings home the functionality that MEMS is bringing to the table. I'd like to thank everybody. I'd like to thank our audience. I'd like to thank our speakers. And all of you, stay tuned for more of these in the future. Again, those of you that may have struggled to download the presentations, we will make sure that the presentation is available through links on the websites. Movea will make it available at their site. We'll make it available on our site as well. And again, we thank everybody for your attendance. Thanks to all the speakers. And to everybody, have a good day, a good evening, good night.